Hi, and welcome to CodeJedi. And in this interview series, we'll be mainly looking into some problems which are majorly asked by the product-based companies in your interview rounds. And most of these questions can be found in Leetcode, HackerRank, HackerEarth, or any other platform. But what we will try to do is we'll try to understand the problem and come up with some solutions. We'll try to come up with the most basic solution and we'll try to optimize it and come up with a better solution. And at the end of the video, we'll even try to write a program for it to see whether our solutions which we devised are we able to write it in a program form to get our outputs. So let's get started. And the first question which we're going to do this video is majorly the merged sorted array. This is a lead code problem with problem number 88. So you are given two integer arrays num1 and num2, and they are sorted in non-descending order. The two integers m and n are also given, which are representing the number of elements in the array number nums1 and nums2. Now our task is to merge nums1 and nums2 into a single array sorted in non-descending order. So we have one more condition. We have the condition given is the final sorted array should not be returned by the function. We should not return the function, the array, but instead store inside the array nums1. So it should be stored inside the array nums. To accommodate this, nums1 has the length of m plus n. The first m elements denote the elements that should be merged, and the last n elements are set to 0. Okay, and nums2 has the length of n. So we are given one example 1 2 3 0 0 with m equal to 3 and nums2 5 6 n equal to 3. The output is 1 2 2 3 5 6. Let's see how we can do it. So the first approach which I could get on top of my mind is we can merge the array. So let's try to do that. Of course, that is a task which we are given, but let you know what I'm talking when we are saying we'll merge the array. So this is the input nums1 and this is the input nums2. The first thing which we'll do is we'll try to append the nums2 value which is here in this nums1 array. Okay, and how we can do is we can take this value and we can merge it here. So basically we are given m equal to 3 and also n equal to 3. So we know that this array length is m plus n. Okay, so now we know whatever nums1 final value ends at m equal to 3. So after this everything will be 0, which is for us to accommodate the final array. Okay, now what we can do is we can append it here. So we can traverse through this array and we can pick it up and we can put it here. We can take it and put it here. We can take this and put it here. So the final array will look something like this: 2 3 2 5. Okay, and now the second step which we can take is we can use a sorting algorithm to sort this array. So we can take any sorting algorithm like quick sort or merge sort, and we can get this sorted and we can get an output of 1 2 2 3 5, which was our required output. Okay. Now let's talk about complexity. So what will be the complexity of this approach which we took now? Now the first step which we did was to append all this data here. We used approximately n operations because this is of length n. Okay, that was the first step. And the second step which we did was we sorted the array. We used quicksort or merge sort. Any sort if we use. Best case which we could get is for this is n log n. Okay, and n here is because this is the total array which we are sorting. So n here is m plus n log of m plus n. So the final complexity will be again yes m plus n log of m plus n. So this will be the complexity. So let's see if we can try to reduce this complexity by any other way. So now we'll take this approach called two-pointer approach, where we'll have 2 pointers, one for nums1 and one for nums2, and we'll keep track of the position where we are in and try to sort the array as well as appending it in the same process. Okay, so what we can do is we can take I which we can make it maybe m minus 1, which is to track the first nums data. And then we can take j, which can be made as n minus 1 to track this. And we can meanwhile keep another pointer, which is mainly to track the final output array which we'll get. Okay, so let's take a example walkthrough for this. In this example, let's have a walkthrough. So now I will be, because m is 3, so I will be 2, j will be again 2, and k will be m plus 1, which is 6, minus 1, which is 5. Okay, so now array starts from 0, so 0 1 2. So here will be our pointer, and again here will be our j, here will be our, okay. So now what we will do is we will see if, yeah, again, yes, we'll see if this 3 is greater than this 6. It is not. Basically what we'll do is we'll insert this k, this 6 into this array. But where should we insert it? We will insert it in this k. Okay, so k is 5. So this was our array. 1 2 3 0 0 0. Okay, now I equal to 2, j equal to 2, and k equal to 5. So we see 3 is less than, like, is not greater than 6. Okay, so whichever is greater, 6 is greater, so j is greater. Okay, and k is 5. So we'll write our positions as well here. Array position 1 2 3, sorry, 2 3 4 5. Okay, now we know that our I is here, this position, and j is here, so k is at 5. So we can replace this with this. So now my this will become, a position 5 will become 6. Okay, and now we will we'll subtract this will become 4, and we will subtract this, and this will become 1. Okay, now because we didn't have anything to do with I, so we just left it like that. Now let's move to the next step. Okay, now we'll again compare I and j. So I is 3 and j, yes, it moved here, it will become 5. 3 is less than 5, yes, it is less than 5, so 5 will go to k of 4, which is here. Now again k of 4 will be replaced by 5, and because we used k, so we'll again reduce this and we'll make this 3. We used j, so we'll make this 0. Okay, now we didn't use I, so we'll keep it like that. And now our j pointer will move and come here to this 0's position. Now we'll compare 2 and 3. We see that 3 is greater. Okay, now this is what I should insert here. So insert it. It is 3 here now. Okay, and this will become 1, and this will become 2. Okay, now let's move to the next step where I will move here. Okay, now 2, is it greater than 2? Not. I'll use this j. What I will do is then make it 2 here. Okay, and this will, because I used here, so it will be 1. Here this will be minus 1. So whenever one of the pointer becomes minus 1, we can exit it out. So this is what one of the approach which I could think of. And in this approach, majorly complexity which will come into picture will be m plus n. Why is that? Because this is the final array which we are basically traversing, nothing else. So this is the whole array which will be traversing. Apart from this, there is nothing else which is happening. So this is m plus n. This is the best best complexity which I could think of to solve this out. So let's go and write a program for this one. So as you can see, I have my open here, and I created a class with sorted array here already. For this class, I already created a test class as well. So in this basically series, we'll be taking the test driven approach where we'll write test first and then try to make a function pass those. If you want to learn how to write tests, you can put out in the comment and we'll surely make a video for that. For now, I already wrote the tests which are needed for this problem to save time. What we can do is we can run this test to see if our function passes. We already see that our test is failing errors. Case where I hover over it to see the error and I see that the merge function is not there, just click here to create method. IntelliJ will automatically create method for us. The public void one our input. Let's make it a little more readable for a use case. So m will be n. Okay, so this is what our input array will look like. Now, as we discussed, we'll be taking the two pointer approach. So I need to create two pointers. This I will be -1, another pointer j be n. Now to keep track of the final array, we also have to create another pointer which will be k, which will be equal to m plus n. This is our created all the pointers now. Now remember we were talking about a condition where either j or I, if whichever one comes to -1, we'll break it. Let's assume it is j for now, while j is greater than or equal to 0. Okay, so this is our condition which we will try to satisfy. This condition is done, we'll break it. Okay, now if I is also greater than equal to 0 and if nums of I greater than of j, basically if my I is greater than j, what I will do is 1 of k to of I am replacing here. I am appending the array there and make it following the values which we saw in the solution explanation above. And now because we used k and we used I, so k minus minus and I minus. If this condition is not satisfied, what I will do is paste here. So I'll have k equal to 2 of j. If my j is greater than I, then of course I will insert j into that. So, because I'm inserting j, so let's run our test cases. Cool. So all our test cases have passed. We see that all our test cases are run successfully without any issues. So yeah, this was one of the approach which we could take, and this is how we could solve this problem. That's all for this video. Hope you were able to understand the approach, solve this problem. The code will be shared in a GitHub link, which will be given in the description. And if there are any questions or any better solution, please do put out in the comments, and we'll surely look into it and try to address it. Subscribe to CodeJedi to stay updated on any more videos coming in this channel. Thank you.